There's another couple of things that you need to understand about a game, and that is a game is an awful lot like the flip books. Anybody make those before when you're a kid or maybe even recently? If you like animation and you want to produce an animation, this is the simplest way to do it. You take a book like this. My mom used to get really pissed because she owned a business and I would use her Post-it notes for this. So she'd go to write a Post-it note and it'd have like little animated figures on every single page of her Post-it notes. But they're perfect, right? They're the right size. They're already in a nice, convenient format. They're easy to flip through. So this is a great illustration for how the game actually works. Because what happens is every time you see something move on screen, it's not actually moving. I don't know if you guys know this, but there's no such thing as a moving picture. There's no moving pictures on any screen you've ever seen in your entire life. There's no such thing. Pictures cannot move. What they can do is change slightly between pictures. And we can change those pictures, just like the pages of a flip book, very rapidly to produce the illusion of movement. So in a game, those things don't move around. The ghosts and Pac-Man don't actually chase each other. What happens is that screen is updated. Sometimes in more modern games, like 120 times per second, if you've got a decent machine and you're running the right game, that's what sort of the professional standard is, right? But a lot of games, 30, 60 frames per second, that's pretty normal for an average, especially like an arcade kind of game. So what we see here is the screen is just like a giant flip book. Those objects move a little bit each time. And what happens is it produces the illusion of movement on the screen. However, this isn't your ordinary flip book, right? Because I'm controlling an object on the screen with my joystick or the keyboard or whatever. And presumably the other objects, the ghosts in Pac-Man or whatever, are responding to my movement in some way. So it's not a flip book, because a flip book, all the pages are drawn in advance. Every time I flip through that book, the same thing's going to happen. But if I play Pac-Man 25 times, it's a different game every time. And so what that requires us to do is every time we're viewing a page of the flip book, at the same time we're viewing one page, we're already drawing the next page. So that's what these two commands do for us. Screen.blit. Blit is a command or a function that draws something on the screen. And you can see the word surface refers to a sprite. It's the visual part of that sprite. A lot of times the surface and the rectangle go together. They're kind of glued together. So when I blit a surface onto the screen, I'm saying use that rectangle's location and put that airplane in that location. But it's not here on this one that we're viewing. It's on the one that we haven't flipped yet. And so while I'm viewing this one, I'm drawing that one. I'm drawing all of the sprites on the screen, and some games can actually have thousands of sprites on screen at once. So we're blending all of those onto the screen in their locations. And then when it's time, we use screen.flip to flip the next page. And that's happening potentially 100 times a second or more. But in our games, maybe 30 or 60 times per second. It doesn't really matter, because what you'll see with Pygame is that that's just a number. You just decide how many frames per second do I want to have. And you can run a game at 120 frames per second if you want to. Nobody's going to notice on a game like this. Nobody's going to care. But what the end effect is that it becomes a measure of difficulty, because you can use that measurement, the frames per second, to actually speed up the whole pace of the game. It's a simple way to do it.